Let's begin with a close look at the components of the constructability modeling workflow. When we as construction professionals are given project information, it is often in a state that is difficult to use immediately for our construction needs. If models are provided, they often lack detail or are built strictly for the purpose of communicating design intent and therefore need to be augmented to fit our needs. We will begin by acquiring our design intent models that will be used as a backdrop for our constructability modeling. We can view and review the models in several ways, the first being with Buzzsaw, with the interactive viewing of models right on the web. Next, we'll open the models in Autodesk Navisworks and Autodesk Revit to continue to interrogate the information provided and begin our planning for constructability. Next, we'll look into how to leverage Autodesk Revit to create the construction detail needed within the models. We will explore efficient ways to reference the design models as a backdrop and create the parts and assemblies needed to add the construction-specific details. Following on that, we'll continue in Revit and extend the design data and information in the model again, specific for construction and the detail needed in order to leverage for downstream activities like quantification, planning, and coordination. We will finalize this workflow by preparing the data and models in our Navisworks environment and begin to explore the model with intuitive navigation and aggregation tools. It is important to note that the Autodesk construction solution ties directly into a data management and collaboration solution that empowers firms like yours to manage, share, and securely collaborate with all project stakeholders both inside and outside your firewall. As we see in this graphic, the Autodesk Data Management and Collaboration Solution is a connector that links workflow components together, enabling project information to be shared at any stage of the process. Contractors often receive design intent models or simple documentation from the architects and engineers. However, in order to really have this information be useful and helpful in driving the construction practice, new levels of information have to be added to the process that account for needs and methods, materials, and how those project components come together. This is really the role that constructability plays. With the Autodesk Construction Solution, BIM or VDC engineers, superintendents, and project engineers can adopt a digital approach that reinforces constructability, bringing their construction knowledge to the project earlier in the process. Something that can limit the usefulness of a model is a lack of construction detail. Take this wall created by an architect. In this example, the wall is modeled as a single object with property information describing the components it is comprised of. From an architect's perspective, a single object may be an adequate representation. However, for a contractor, you may need to understand and investigate the order in which each subassembly is built, along with relevant impact on the surrounding trades or logistical equipment. Design intent models can be further modified, dividing slabs into individual concrete pours, breaking partitions to show accurate wall construction, or merging components together to better represent how the elements will be constructed in the field. Here we see a specific profile being added to the cast-in-place wall segment. This capability is important. We can account for details specific to how the wall will actually be constructed, in this case an expansion joint detail or a conduit chase. Being able to add this detail to the models and being able to do it without editing the original design intent is an important benefit of leveraging the Autodesk Construction Solution that saves time and ensures accuracy in the field. Leveraging the displaced view capabilities within Autodesk Revit, a contractor can create an exploded diagram of building components, details, or other aspects of the model where further detail is needed. Here we see how displacing elements of a floor connection detail can enhance the documentation needed in order to accurately communicate how the wall and floor sections are coming together. The displaced elements can be used to create a better picture or view of the details, but can be further enhanced with appropriate annotation and placed alongside the traditional details on a sheet in the plan set. By driving this level of information into the process, you are better able to derive more granular insight into quantities, coordination efforts, and construction sequencing.